Hi there. So today we're going to be talking about infinity. So infinity is represented by the figure 8 symbol and is defined by n is equal to n plus 1. There are various forms of infinity, such as the number of values within the natural, rational, integers, real numbers, and the complex numbers. Within those domains, the values are absolutely infinite, or the number of values, sorry, are infinite. And also the number of decimal places on irrational numbers such as pi, square root of 2, square root of any prime number to be realistic, and e are also infinite. And anyway, so we're going to be talking about the varying degrees of infinity. So the way that we'll discuss this is through the number of values within the natural, real, and complex domains. So within the natural numbers, again, that's 1, 2, 3, etc., all the way up to infinity. So an infinite amount of positive integers. Now, between each pair of positive integers within the natural numbers, say 1 and 2 or 1 and 50, doesn't really matter, there's going to be an infinite amount of real numbers. And what that is essentially you're taking the space between two positive integers and you're breaking it up infinitely many times. So that's for example, you're partitioning it infinitely many times, similar to what you do with an integral. And so you're able to do that between any pair of numbers within the natural numbers. So, but again, there are infinite amount of pairs. So this means that there are 2 degrees of infinity within the real numbers. There's the actual length of the numbers, so say 1 to infinity. But then there's also the fact that between each pair of integers, there's also an infinite amount of numbers as well. So right there you have 2 degrees of infinity. So if you will, we have, if we were to imagine this as two-dimensional graphs of Cartesian plane, for example, the x-axis could be the natural numbers, and then the y-axis could actually be the real numbers regarding planes of infinity. And so now what we're going to do is we're going to bring the complex numbers into this. So regarding the complex numbers, for every single real number, let's say 3 for example, because it's fairly simple. Anyway, so we take 3 and we can add an infinite amount of complex parts to it, because recall the definition of a complex number is x plus yi, where I is square root of -1. And anyway, so if we have a fixed x, 3 for example, and we could vary y indefinitely, we could have any real number there. And so because of that, for every single real number, there's an infinite amount of complex numbers. So there's your 3rd degree of infinity. So if we were to now imagine the 3-dimensional plane where we have axes x, y, and z, then x is still our natural numbers, y is still our real numbers, but now z is our complex numbers. And so from here you have your 3 varying degrees of infinity. Now you couldn't really plot anything within this. This is just for visualizing the varying degrees of infinity, but it's interesting to see how infinity can be multi-dimensional regarding conceptually anyway. It can be conceptually multi-dimensional when you view it, when you analyze it like that. So anyway, I hope you found this video interesting, and I'll be posting some tutorial videos soon. Anyway, have a good night.